All right, so let's have a look on how we can do this question here. Here it says a boy throws a ball at a target at the instant when the ball leaves the boy's hand. At the point A, the ball is 2 meters above the ground. So we can see that's 2 meters above the ground and is moving with speed u at an angle theta above the ground. So in this case, one thing that I'll do straight away is we have this triangle and we can find the vertical component of that velocity. So therefore, this component would be one of them, and then you have the vertical components as one of them. So the vertical component would be u sine alpha, and the horizontal component will be u cos alpha. So that's how we can split that into the vertical and the horizontal components. All right. So in the subsequent motion, the highest point reached by the ball is 3 meters above the ground. So when it reaches the highest point, velocity is equal to 0. So velocity in the vertical component. So in the vertical component, the velocity will be equal to 0 whenever it reaches the highest point. So that's, again, applies to everything. So always remember that. The target is modeled as being the point T, as shown in figure 4. The ball is modeled as a particle moving freely under gravity, so that's important. So part A is use the model to show that u squared is equal to that. So let's try to do part A. So one thing that's very important to understand is the vertical component and the horizontal component. So in the vertical component, let's start with vertical. You use SUVAT all the time. So you use SUVAT to solve it. In this case here, and then you find that, and that's for the horizontal component. Vertical component. And in the horizontal component, there is only 3 things that you need to know. In the horizontal component, acceleration is set to be 0. So the object should always move a constant velocity horizontally. And horizontally, the only 3 things that we need to consider is speed, distance, and time. So there's only one formula that you can apply horizontally, and that's speed equals distance over time. So that's the only formula that you should be applying in this case here. So I'll write it here. So speed equals distance over time. So you have to only use that in this case here, whereas in vertical, in this case here, actually, we can write SUVAT. In this case here, you must use SUVAT in this case here, and we know all the formula for SUVAT. And in fact, we can just change this a little bit here and be like, okay, here the acceleration actually is acceleration would be, in this case, would be gravity, whereas in this case here, acceleration is equal to 0, because the object moves a constant velocity throughout the whole journey. So let's have a look at this in this case here. So as I said, in the vertical component and in the horizontal components, we have to treat it differently. So vertical components, we have SUVAT. So in this case here, we have to consider only up to the first point. So let's consider with the information that we have. So they tell us that the ball reaches 3 meters above the ground. So let's consider from this point, the starting point, to only that point there. Why, you might ask, why are we picking the highest point and not the T? Because we have more information for the highest point compared to T. So that's what we compare. We're taking that information and we're using the 3 meters as being the highest point. So in this case here, we're going to take our upwards as my positive value and as going to the right as my positive value, my positive direction. So in this case here, the first question that we need to ask ourselves, what is the distance traveled? From A to the highest point, we only traveled 1 meter. So displacement is the difference of how far you go from the starting point. So from the starting point to the point T, our displacement would be 1. What would be the initial speed? So the initial speed, we have to look at vertical components, and that would be our u sine alpha. What is my final velocity? As I said, final velocity here vertically will be v equal to 0. So as mentioned already down there, so I'm writing it over and over because that's really important to understand. And what would be my g? So what would be my acceleration? My acceleration, of course, is going to be my gravity, but gravity pulls downwards. So because I'm going opposite of gravity, my gravity will be minus g. And my time, well, I do not know what my time is. I'm not sure what that is. And now let's try to think about it in the other components. So in the other components, what we have in this case here, we can also find the speed. In this case, will be simply u cos alpha, and we keep it the same throughout the whole journey. Well, we don't know the horizontal distance and we don't know the time. So actually we can see that in this case here, in part A, there's not really advantage of doing anything horizontally, because horizontally you simply speed equal distance over time, and we only have the speed, so we have two things missing, so we cannot do anything horizontally, so we have to focus vertically. So in this case, looking at the information that I have, the equation that seems the most suitable, I have to find an equation that uses not time and uses everything else apart from that. And one equation that I can see the u is also squared, and that will be, I can use the following formula, which is v squared is equal to u squared plus 2as. And this is the formula that I'm going to use in this case here. So my v in this case will be equal to 0. So it will be 0 squared is equal to my u squared, which is u sine alpha squared plus 2 times minus g times my s, which in this case is 1. So that becomes 0 is equal to u squared sine squared alpha, and 2 times minus g times 1 is minus 2g. So in this case here, if you take the minus 2g to the other side, so that becomes 2g is equal to u squared sine squared alpha. So in this case here, my u squared, if I make the u squared the subject as they want me to do, so my u squared simply becomes 2g divided by sine squared alpha. And that is part A complete. I've shown that, and I've got the 2 marks for part A. So now let's move on to part B. So part B, let's have a look what we need to do for part B. So part B is telling us the point T is at a horizontal distance of 20 meters from A. So from here, from A to T, the horizontal distance will be 20 meters. So that's very important. And at a height of 0.75 meters above the ground. So from there to there, the distance is 0.75 meters. So for part B, we have to restart the question. We have to consider the SUVAT once again from that perspective. So let's try to do that. So I have my vertical components. So my vertical component, again, is going to be my SUVAT. So SUVAT. And I also have my horizontal component. And my horizontal component is 3 things, which is speed. Just not to confuse with the displacement, so that's why I'm writing the full word. So speed, distance, and time. So those are the 3 things that I need and I know. So in this case here, what's my horizontal speed? Well, my horizontal speed does not change at all, and that will be my u cos alpha. What is my distance horizontally now? From the starting point at A to T, my horizontal distance will be 20 meters. Do I know my time? Not really, so let me put a question mark there in this case here. Maybe in this case, I can, given that I have 2 values for my horizontal, maybe I can try to find my time using those values there in this case. So, and for the vertical components, I have my SUVAT. So what is my displacement? Well, I was 2 meters above ground. Now I'm 0.75 meters above ground. What is the distance traveled? Remember that this line that I've drawn, this is where s equal to 0. That's your starting point. So from there, when you travel this distance here, so that will be the distance that we need to calculate, and that will be 1.25 meters, given that the whole thing is 2 meters. So the distance I've traveled in this case here, that will be 1.25 meters. My initial speed, again, I'm taking, again, I did not mention it, but I'm taking my right as my positive and upwards as my positive in this case here. In fact, if I do take upwards as my positive, in this case, my displacement will be negative, because any distance I travel upwards will be positive distance, but anything is below this s equal to 0 will be my negative displacement, because I'm going away from that in a negative way. And as I said, upwards is positive. So in this case, my u will be simply, my u is pointing upwards, so therefore that'll be more positive u sine alpha. What is my v? Again, I'm not sure what my v is. I'm going to put a dash there because it has not been given, and I probably won't have to calculate it, but let's see. What is my acceleration? My acceleration, again, is gravity. Again, which way initially the object is traveling away from gravity, so therefore that will be minus g, and we know that gravity goes downwards, so therefore we're taking upwards and more positive, so therefore gravity will be negative. And what is my time? The time, again, I'm not being given, so I'm going to put a question mark there. So in this case, I can see that both equations in horizontal vertical components, I don't know what the time is. Maybe I can find the time horizontally and put it back into the vertical component. That is an option to do. That will allow me to find the size of the angle alpha. So let's have a look at that. So in this case here, if I look at it horizontally, so I know that speed equals distance over time, right? So I can make my time the subject. So my time in this case here becomes distance over speed. So if I'm trying to find my time in this case, my time will become distance, which will be u cos, sorry, that's wrong. My distance is 20 divided by u cos alpha. So that's my time in this case that I can take on board. And now what I can do is the point t, the time will be equivalent whether you travel horizontally or vertically. So in this case, I can rewrite my t as 20 over u cos alpha. So this is where it can get a little challenging. So be with me, stay with me. So in this case, let's have a look now what we can do. So now horizontally, we found time in terms of the speed and distance using the values. So now let's go back to the vertical components. We need to find the angle alpha. So what is an equation that combines displacement, initial speed, acceleration, and time? That will be simply the following formula, which is displacement is equal to initials ut, s equal to ut plus a half at squared. So now let's substitute in everything, all the values in this equation here. So if I do this, that becomes minus 1.25 is equal to my ut. So my u in this case here is u sine alpha times my t, which is 20 over u cos alpha plus a half, and my a is minus g, and my t squared in this case will be 20 over u cos alpha all squared. So let's try to move a bit more on the left hand side. So that becomes minus 1.25, and what happens here is my u and my u cancel each other out, and therefore that is equivalent to 20 sine alpha over cos alpha, and in this case here that become minus g. In this case I can do, so it'll be minus g over 2, and if I expand it on this side here, so that can be rewritten as 20 squared if I square it, so that becomes 20 squared, which is 400. So 400 over u squared times cos squared alpha. So I squared every single element that I have in this case here. So I can now simplify this to minus 1.25 is equal to sine alpha over cos alpha is tan alpha. So I can rewrite this as 20 tan alpha minus g over 2. And now that can be written as 400 over, well, I know what my u squared is, right? So I know that u squared is simply equivalent to 2g sine squared alpha. So I can substitute that in there. So u squared simply becomes 2g over sine squared alpha times cos squared alpha. So that simplifies down to, let's go to this side here, and that becomes minus 1.25 is equivalent to 20 tan alpha minus g over 2, and that becomes 400, which in this case we could actually simplify a little bit beforehand, right? So actually let's keep it like this for now, just that we don't get confused. We can write 400, and you have that big division sign, which we can rewrite as just a division sign like this, and we can simplify the denominator in this case. So the denominator simplified, that gives me 2g cos 2g cos squared alpha all over sine squared alpha. I close both brackets, and let's go to the next line. So minus 1.25 is equivalent to 20 tan squared, tan alpha minus g over 2 bracket. Now in this case here, we're going to be applying the KFC method, and it's not what you think. It's not a fried chicken, but we're going to do keep, flip, change. So we're going to keep the first part. We're going to flip the second fraction, so that becomes sine squared alpha over 2g cos squared alpha. And now we're going to change the sign to a multiplication. So now this simplifies down to minus 1.25. So maybe I should not write the equal sign at the beginning. So minus 1.25 is equivalent to 20 tan alpha minus, if you multiply them together, so that becomes g over 2 bracket 400 sine squared alpha over 2g cos squared alpha. So in this case here, what we can do is we can cancel out the 400, so that becomes 200 over 1. 402 simplifies out, and we can then, if I do take it one step further in one go, so the 2 and the 200 then can cancel out further, that gives us 1, that gives us 100. And the last thing that we can cancel out as well is we can cancel out the g with that g. So I know there's lots of cancellation going on, so what came out of that alive is minus 1.25 is equal to 20 tan alpha, and in this case here that will become minus 100, will be minus 100, and sine squared alpha over cos squared alpha is same thing as saying tan squared alpha. Now let's try to get this into a nice quadratic format. So I'm going to take minus 100 tan squared alpha and 20 tan alpha to the other side. So if you rewrite it properly, so that becomes 100 tan squared alpha minus 20 tan alpha minus 1.25 is equal to 0. So if I take if I put this into my calculator, or you can use the quadratic formula, so therefore it should give me my tan alpha as 1 over 4, or my tan alpha as equal to minus 1 over 20. So in this case, because my angle needs to be positive, I'm going to ignore the negative sign that I get, and I'm going to focus on tan alpha is equal to a quarter. And from there, if I put the inverse of tan minus 1 over a quarter, it gives me alpha value as 14.04. And that will be my answer in this case here for the alpha value, which is what they requested in part B. So that's how you get that 9 marker correctly. Probably it is a lot of more steps than I would have done normally, but it's very important that you do the steps here. 1, to prevent from silly mistakes. 2, if just in case you had any mistakes, you have method marks that you will be receiving in this case, because you have done it so thoroughly. And of course, if you use the right method, you'll get the marks for those as well, for that as well. All right, so now that's part B done. So now let's have a look on how we can do part C. Part C is telling us state one of the limitations that we can that of the model that could have affected your answer to part B. Well, in this case, we said horizontally the object always travels at the same speed. Realistically, this is not possible because we have air resistance, for example, and that would be one of the limitations of the model that could affect the answer, and we can mention it. So part C, we can say that air resistance would change the answer. So so that could be one of the things that can affect it in this case here. All right, now and then looking at the last part. So the last part is telling me to find the time taken for the ball to travel from A to T. So this is going back to defining the time in this case. So what we know that we can do for this. So we know what our alpha value is equal to 14.04 0.04. So in this case, in order to find my value of my time, so my time, I got the equation for time. So time is equivalent to 20 over u times cos alpha, right? So once I know that, I can find what my time is. So at the moment I know my alpha, but at the moment I'm missing my u. But hang on a minute, I know also that u is equivalent to what? So u squared is equivalent to 2g over sine squared alpha. So u is equivalent to square root of 2g over sine squared of, I'm going to put the value here, which is 14.04. And if I put this, I get the u value as 18.24898 dot 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 dot. So I know that my u value now, what that is. So this is my u value. Now I can take that value and put it into time. So my time is equivalent to as 20 divided by my u, which is 18.24898 times my cos of 14.04. And if I do this in this case here, put this in a calculator, then from there it gives me a time as 1.129 dot 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 dot, and therefore I can round up my time to 2 decimal places as 1.13 seconds. And that is the time that it takes for the object to travel from part A, in this case here. Let's show the path. So from part A in this case here to all the way to value point T. So that distance, it takes 1.13 seconds. So hopefully this question is all clear now to you. So it is quite a lengthy question that you can have in the exam. This is an exam style question that I went through. Again, I want to emphasize that it is not a very hard question if you know exactly the steps you need to take. And the where students loses marks is they make silly mistakes, and I think that overall makes the question difficult, like in terms of it's a snowball effect. You get one part wrong, then the next part will be wrong. So it's very important that you're doing everything step at a time and you're not rushing through this process, and you're breaking the question down as much as you can for each part. That can help you answer the question in a timely manner, as well as that without making silly mistakes. If you have any questions, please do let me know in the comments down below. But hopefully this question now is all clear. Spend some good time understanding the fundamental of this question here, and if you can really understand that very well, you should be able to answer any projectile questions without any issues. All right, thank you for now.